Guys, okay. Testing, testing. Yes, okay. 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 Hello guys, good morning. I hope everyone is good. Yeah, so we will be continuing from where we left off last week, but yeah, let's just say I'll start over, but we'll be working much quicker today, right? I assume that people had the chance to watch the recording, and I hope people saw the second recording that I made that was correcting last week's error that I was struggling with. So basically, the reason why our simulation couldn't run successfully, it was because of a setting issue that I overlooked, right? So I hope everyone got the chance to watch those two recordings. Not of the head, not of the head. Okay. Anyway, so I'm just going to introduce the topic again. So it's Electro Pneumatics with PLC again. So we'll be using ladder logic language in order to control our fluid sim, right? Our pneumatic circuit, right? So let's open codices and fluid sim and start setting up the two software so that they can communicate together, right? So yeah, the guys in the chat, can you please send the link, the meeting link to the guys that are not in class? We changed a link so that it can, what's this? So that it can automatically allow students to enter the meeting. Okay. And I also would like you guys to open your what you call your lab guide, right? Because we'll be going back and forth the lab guide. Okay. Okay. Once you open your codices, you can just cancel this window, and also this window, right? And then you'll go to new project, right? So guys, we are setting up the codices platform first, and then we'll set up we'll set up fluid sim. So you're opening a new project. As I said, guys, I'm gonna be working a bit more faster because I covered this last week, right? So yeah, it's just for revision in a way of how to set up. Moving forward, you have to set up on your own, right? So anyway, we're gonna quickly name this whatever you want to name it. Automation, automatic control. You can name it whatever you want. But then obviously in the test, you must name it using your student number, initials, and surname, right? Okay, and under templates, you always choose a standard project, right? And then you will click OK, right? Then you'll just have to wait a bit whilst the software buffers so that it can load a new page, right? Yes. Unfortunately, I can't. Yeah, might we have a remote to control AC? Is it too cold or is it too cold? Our students, huh? Too cold. But guys, you are aware that we have to have fresh air, right? Yeah, okay, but I think mechanical engineers, they deal with the HVAC, so can you guys do something about that? I don't know. You don't deal with air conditioners. Um, yeah, guys, I really don't have a remote, so I don't know. I don't have a remote. So, yeah, we'll just have to, yeah, big as hell, I think. Excuse guys. Anyway, so your PLC program, you must always keep in check that it's in ladder logic diagram, right? That's the language you'll be using, right? And then you click OK, right? Then after that, there'll be functions on the left side here. Then before that, we'll on the ribbon there at the top, you'll go to the online tab, right? You'll go to the online tab and then always select simulation. And then once you can click again on the online to double check if your simulation is ticked right there, right? And then you will go to application. You'll click once on application, and then you will right click, okay? And then we'll go to add object, right? Add object, and then go to symbol configuration, right? And then you'll click on symbol configuration, and then you'll check one box. There are two boxes. You'll check the one that says support OPC UA features, right? And then add. You click add, right? And then afterwards, you'll have to go and put in what's this? We'll have to go to put in our variables, right? Our inputs and outputs. I believe that for this section, I mean fluid sim with PLC, you will have to memorize only six variables, right? So for this lab, we'll have um, I0, which is our start button. So how you define that is by typing I0 at I percentage IX 0.0, right? And then you put a colon, and then you assign this variable as a Boolean data type, right? Meaning that it can only take two values, true or false, right? And then you end off with a semicolon, right? And then remember I told you how to comment, and I informed you what a comment is, right? A comment basically is text that you write so that you as the programmer or someone else can easily understand what your code implies, right? So for our case, our first input, uh, our first variable input is our start button. So we can name it PB start. Then going forward, we can just copy and paste this. Copy and paste up until we have five, five inputs here. So first of all, what we're doing here is defining inputs, right? Okay, so input number I1 at 0.1, that will be our stop button. PB stop. You want to be stopping your process at any time. You want to be having full control, right? And then you have I2 at 0.2, excuse me. And then that will be our EMG, emergency stop button, right? It's actually low when engaging with. Can someone please pause? I mean, mute the speakers there, because I can hear myself, and that's not nice. Okay. All right, thanks for that. So we always have to have an emergency stop, because you want to prevent injuries. You want to have full control of your system, right? And it's law that you always have an emergency stop, right? I'm sure you saw that in your learner guide if you went through that, right? And then we have our is someone saying something? Okay. So we have our sensor, right? For this lab, we also have a sensor, sensor 0, which is proximity sensor 1. I mean sensor 0. And then we have proximity sensor 2. Before that, I forgot to add it here, so it's 0.3 here. And then sensor 2, it will be 0.4. And then you can also label that as proximity sensor 1. Okay, then after doing this, we are done with our inputs, right? Now we can go on to define our outputs. So it's as easy as also copy. Yes. Oh, sorry about that. It should be S1. Thanks for that. So yeah, we have two proximity sensors, sensor 0 and sensor 1, right? And then we are now defining our outputs. With our outputs, you can easily copy and paste this information below here and just configure accordingly, right? So we'll have Q0. So yeah, just keep in mind that we'll only be using two outputs, right, for this section, right? So we'll have Q0 at instead of I, it will be Q, right? QX 0.0, right? And then this will be our solenoid 1, right? Solenoid 1, right? Then you can just copy all of this and paste below. Okay, and then we have Q1 at QX 0.1. And this is just solenoid 2, right? Or you can just let's remain consistent. So it will be solenoid 0 and solenoid 1. And then we are done with defining our variables, our inputs and outputs. So yeah, this is these outputs. Yes. Okay. So these are all the inputs and outputs that you have to memorize, right? And yeah, you can see it's not really a lot of things to memorize, right? So yeah, once we are done with this, is everybody done here? Okay, I'm just gonna give you 2 more minutes to finish up, right? Yeah, remember to use copy and paste, guys. It's the greatest invention ever made. So yeah, remember that. You don't have to type out everything.
Is it unreasonable for me to look for someone with a bachelor's degree or higher from a similar university?
As you continue
Salary is
working, let me check up on the guys online if everything is okay.
with an annual salary.
The guys online, is everything okay? Can you hear me?
Is it
Am I
unreasonable
audible?
for someone born around 1990, plus or minus
The
3 years?
response would be appreciated.
I have 300,000 RMB in savings. Is it unreasonable for me to ask for a dowry of 280,000 RMB?
Oh, yes. Oh, thank you very much. Thank you very much. Thank you very much.
What are these requirements?
Yes.
Motivate someone like me?
You mean here at the top here? Yeah. Yeah. It's. I'm not gonna give marks for commenting, or I'm not gonna deduct marks for commenting. Remember, comments, as I said, is just to inform me and yourself of what you are doing, right? So I can know what you meant in this code, right? So yeah. And another tip, please multitask, don't stop doing what you're doing. Another tip is as you are putting in your inputs and outputs, defining your inputs and outputs, always double check if you haven't repeated an output. For example, what I mean is at I0, if you said IX 0.0 and I1 you said IX 0.0, you'll have an error, right? So it's very essential to always double check, even triple check your inputs and outputs so that you do not get errors, because once you get errors, during a test you start panicking and you lose all logic. Logic flies out the window, right? So it's only, and when you look back, you'll be like, oh, it's because of this and that. I didn't define my inputs correctly and whatnot, right? So just make a habit of double checking if all your inputs and outputs are okay, right? So I'm gonna move on, guys. We don't have time. So I hope everyone is finished with defining the inputs and outputs. Otherwise, yeah, we just have to refer to the video, right? To the recording. Anyway, so once we're done with this phase, we'll have to now go to symbol configuration to build, right? But before that, you have to go to settings. Go to settings and enable direct I/O access, right? Input output access, right? Then we'll click on that, right? And then you'll click on view, and then you click on unconfigured from project, I believe. Okay. Okay, let me click build and see something. Okay. So after setting and enabling direct I/O access, you'll click on build, and after which you will see three symbols: constants, I/O config globals, and PLC program, right? And then this is where you'll check all the boxes, 1, 2, and 3, right? Then once you have checked all these boxes, you'll go ahead and click build again, right? And it's always good practice to click build twice, right? Double click, click twice, yeah, you can do that. And then, yeah. And then once you're done with that, I believe you are done with your setup of your codices, right? But now you have to now go to Fluid Sim now to set up Fluid Sim. But before that, I would like for us to build, to put on circuits before we configure our Fluid Sim. Yes. Sure. To the output. Okay, and another thing, make sure on your input outputs, all your inputs and outputs are under var, and the last piece of code is end var, end underscore var, right? Just make sure your inputs and outputs are are between those two pieces of code. Okay. All right. So we're now gonna go to fluid sim to build just a simple circuit. So we're gonna start off with basics, right? So let's have our supply elements, your compressor, a service unit. Then we can just rotate by 90 there. Okay, and then we'll go to valves and frequently used wave valves. And then, as always, we're using solenoid operated valves. And then we're gonna choose a normally closed 32-way solenoid valve, right? And then we're gonna label it Q0, right? And then we're gonna click OK. And then we're gonna just connect those two. And then lastly, we're gonna have let's have a a one-way flow control valve, so that we can regulate our flow rate, right? So what we want is so in this exercise we want our cylinder to, so this cylinder that we'll be using, it's a cylinder with a spring return, right? So you'll find it under actuators. So a single acting cylinder. So we're using a cylinder that has a spring return, meaning the cylinder retracts automatically. But we want to control how fast it goes back, right? So that hence we are using a one-way flow control valve, right? So let's just put that at 5% and then display the opening level. And then you'll check the display opening level if you want to see the 5% on your circuit, right? And then you'll click OK. Okay, and then we're just gonna connect those. Okay. All right. Yeah. And then we're done with our pneumatic circuit like this, right? Okay. So let's just assume that the exercise is about diverting packages. You remember that exercise from last term? So let's say we are diverting packages that are maybe not meeting quality standards, right? Then let us put our electrical circuit. Let us connect our electrical circuit. We'll go to electrical controls. Under power supply, you'll put your 24 volt there. Then you connect that. And then we have our 0 volt there. Then you connect that, right? Okay, because okay, after this, we can now start putting our inputs, right? So we'll put all our inputs. We'll first put our switches, and then we'll go to manually operated. And then for our start button, we'll have a normally opened push button, right? Or start button. And then we will have a stop button, which is the fourth component, D-dent switch brake, right? And then we'll have emergency stop button. Now, if you can observe, our stop buttons our stop button and emergency button, they are normally closed. This is like the industry standard, right? So just keep that in mind, right? So we're just gonna label our buttons, right? So please label appropriately. So we can label it PB underscore start, or we can just say PBS, push button start. And then we can name this PB PB stop, or yeah, PB stop. Okay, then we can name this EMG, emergency stop button. Right. And you can just space your items nicely. Okay, and then we have also our sensors. Okay, so for the entirety of the sessions, we'll be using what we call magnetic proximity switch or sensor, right? So magnetic proximity switches are used for position sensing, right? And if you can go back to last term, we were using limit switches, right? Now, limit switches, they also work as they also assist in position sensing, but the difference between the two is that unlike a limit switch, a magnetic proximity switch or sensor, it doesn't need contact, like it doesn't need to be in contact with the object, unlike the limit switch, right? I'm just gonna quickly put on a limit switch so that I can demonstrate something. So let me switch. Okay, let me put this on. Okay, I'm looking for the picture, but let me just go to Google to show you. Okay, so if you can look at these pictures here, these are what we call our limit switches, right? Now, with our limit switches, how they work is only when should I what you call? Let me click into this. Okay, cookies. Okay, so with our limit switches, how they work is, and I'll also show you guys a video, right? So with limit switches, you have a sort of a rolling wheel, right? So if that object comes into contact with this rolling wheel, it will now close a contact inside this switch, and that switch will now, once it's closed, it will send a signal, right? And so that whatever output, so that it will send a signal to an output, and yeah, the output it'll either be like maybe a cylinder diverting an object, or a cylinder drilling an object, or yeah, a cylinder closing an object, right? So that's how your limit switches work, right? And then you have your proximity magnetic. Okay, and then you have a magnetic proximity switch. So a magnetic proximity switch is used to switch when a magnetic field approaches, right? So it belongs to the group of magnetic sensors, and its peculiarity is the contactless switching technique. So as I said, it doesn't really depend on the object. It doesn't depend on contact between the proximity switch and the object, right? And I saw a video on YouTube that I think it'll go a long way in you guys understanding what we are trying to do, right? Okay, you cannot, connection is not private. So EJ is not allowing us to access YouTube, right? But it's okay. I will upload the video so that you get a better understanding of what a magnetic proximity switch is, right? But yeah, with what I've explained, just keep that in mind as we're moving forward, right? Yeah. So anyway, let us put on a second proximity switch. Okay, we're gonna put another proximity switch there. Then we're gonna name this as 0, and we're gonna name this as 1. Okay, then we're gonna have our outputs, right? Our solenoids, valve solenoid. So we're gonna put 2 of those, right? And then we're gonna name it Q0, and then we're gonna name this Q1. Right? Okay. Now, because we are working with codices, we are now using PLCs to control our pneumatic systems. We're going to have to now use what we call, we'll go to easy port, right? Just a second. Okay, so go to easy port, and then you'll select fluid sim out and fluid sim in, right? So these modules are important if you are to establish a connection between your codices and fluid sim, right? And now someone said something about connections. So now this is when we start connecting, right? Okay, let me just place my items nicely. Okay, so yeah, we'll connect the 3 to the 24 line, the 1 to the 24 line, the 1 to the 24 line, power line, and then we'll connect our 4 to the 0 port, and then port number 1 will be connected to port number 2. Then port number 2 of the emergency stop will be connected to port number 2 of our module, right? And just make sure your lines do not like cross, otherwise you'll get an error. But there is a case whereby you don't get an error whereby lines cross, and of which you'll see when we're connecting our sensors here, right? So we're gonna connect this port here and this port here. Okay, and then now for these ports here, you have to connect to the 0 volt line, right? So we're just gonna put 2 0 volt power lines there. Why is that? Because also these ports here are already connected to the 24 volts, right? Then you can just put another 0 volt there. Okay, just gonna connect those 2. Okay, so we're gonna connect this end to this end. So yeah, it's important you pay attention here, right? It's easy to mix up the connections. You can easily connect this port to this one here, and that might mess up your connections, right? So we'll connect this one, this side, to port number 3 here, and then we're gonna just adjust it a bit, right? Okay, and then we're gonna connect this one to number 4. Okay, and then we're gonna just adjust a bit. Okay, so let me just start over here with the connections. So I get it at the top port here is connected to the 24, and then the bottom one is connected to the 0-volt line, right? I'm saying these ones at the right, these ports at the right, they are connected to your fluid sim out port number 3. And then this one is connected to but port number 4. Are you okay now? Sorry, I'm saying something. Okay, so we'll now connect our outputs, right? Like that, and like that, and then this port to the 0-volt line, and this port to the 0-volt line. Okay, if you're still working, huh? Sorry? Can you speak up? Okay. All right, I'm gonna give you 2 minutes to just quickly look at the connections and just make sure you have done what we have done, and we're gonna move on, right? So if you're getting errors, it's because your lines are, huh? You're getting errors on choruses. That might be, check your variables. One of the problems might be on your variables. Check if like you didn't put an O as a 0, because I tend to make that mistake. You'll put an O as a 0, and O it's a letter, not a numerical value, right? So just double check that. Sorry? This one. I'm sure it's a small thing that you're missing there. Is your partner okay? Is his Nyafana? Yeah, I don't know what to say. Just yeah, just you'll just follow what we did in the recording and just start over. Starting over also is another good way. So yeah, yeah. So anyway, we're now moving on, right? So we're done with putting all the components we'll be needing, and we now have to set up our fluid sim, right? So we'll have to go to options. Before that, let me just press play so that I can see if I don't have errors, right? Okay, so, okay, I forgot something. So on fluid sim out, right? Okay, before that, you have to go to options, and then you go to easy port or OPC or DDE connection, right? It's the second option there. You'll click on it, and then you'll click on OPC mode, right? And then after you're done with that, you will click OK. You don't click anything else, you just click on OPC mode and you click OK, right? And then you'll go to your fluid sim out and double click on it, as so, right? And then you'll see two blocks there, two input blocks there. You have OPC server item, right? So next to your item there, on the right, you'll click on browse, right? Leave that browse at the top. You will click on the second one at the bottom, right? And then you will see this window, choose item, right? And then under root, so you have browse items. Under root, you'll click virtual PLC, right? Once you click virtual PLC, you'll select the first item, the AB1, right? But we're gonna need to reconfigure this, right, to EB0. So this is just the item for your inputs, right? So E, if you can memorize, E stands for your inputs, right? And then you just click OK. And then you click OK again. And then we go to set up your fluid sim in, right, at the bottom there. And then we repeat the very same step, but there'll be only one slight change, right? So you'll click browse, and then you'll go to virtual PLC again, and then you'll click, you'll select AB1, right? But the only difference is you just change the 1 to a 0, right? So this item is for your outputs, right? And then you click OK. And then you click OK again. And then you are done with your setup, right? And then the last setup is setting up your Easy OPC version 5.7, right? So you'll see that pop up. You'll see that app pop up. I don't know if can you see it? Yeah, it's in orange. You'll click on it. And then you'll see this window, right? One thing you must observe is under device, like there's a device state and then there's a device there, right? So the last device, the codices, the driver is installed V3 version 3, right? And then the state is disconnected. So if you see this kind of a state, it means that you'll never have a connection between your codices and your fluid sim, and hence you'll have the problem that we experienced last week, whereby our cylinder was not going forward, right? So, and the other thing to observe is on this flow chart, you must make sure that your connections are from process simulation in fluid sim to codices controller, right? So how can we now get the state from disconnected to connected, right? You'll have to go to the last tab there, codices. It's a tab which has a red, yellow, green sort of icon, right? You'll click there, and then you'll go to settings, codices, right? So as you can see, still there at the bottom left, the state is disconnected, right? So say settings, you'll say settings codices, and then it's on version 3, right? And then you'll click OK. Okay, the status still hasn't changed. Yeah, can you assist us with this error here? Oh, press play. Okay, so if we can, okay, once we press play on our simulation, we'll see that it's connecting, right? What's up? What's up? Wait.
No, you haven't connected anything yet. You haven't yet connected yet. It can't connect without you doing this.
We're not running anything, just the setup.
Yeah, but remember this cannot connect without. Yeah,
Oh, okay.
yeah. Only once this one is connected,
Okay.
you can connect.
Okay. So guys, what we need to do so that for your state here to say connected to localhost, you need to also come to your codices and press. So you'll have to press login here at the top. So next to application device PLC logic, you'll click on login here, right? And then once you have done that, you will see that on your Easy OPC, your connection here will say, let me just do this. Your connection will, from where? From where? Where did I lose you? Yes, press yes. Can I just come and see quickly then? Okay, guys. So once you are connected to localhost, it's not connecting. Okay, so let's check some of the things. First of all, check if your virtual PLC is EB0, AB0, and then also just double check if your easy port is on OPC mode, and then also check. Also try building, and then once you're done with that, go to log in here. Just log in here. So I'm just gonna log out, and then so next to application device PLC logic, go to login, right? And then just check if it has connected for you. Is it still the same? It's connected. Okay. Okay. Also press play, like press play. Also press play. It's not. Okay. It says it's connecting. Then it's gonna be fine. It's gonna be fine. Once you start running, it'll be fine. Okay. Huh? It's still connecting. Yeah, it's gonna be okay. It's gonna be okay. Okay, is everybody connected to localhost? How many nodes? Can I see how many nodes? Okay. Yeah, you guys must have missed something. Okay, just try by closing, logging out, and okay, let's do this. Stop first. Also sequencing matters, right? So just stop first and then log out, right? And then just first things first, let us double check your variables if they are okay, right? And then if they're okay here, just go to your fluid sim. And then stop simulation, and then just double check, go to options and go to easy port and check if you're on OPC mode. Otherwise, also go to your fluid sim out and make sure that you're on EB0, right? Check if you're on EB0. Okay, and then click OK. And for your fluid sim in, check if you are on AB0, right? And then click OK, right? And just make sure all your connections are okay. And what's this? Press play, right? Press play. Okay, before pressing play, just stop there. Go to OPC and go to codices, and then go to settings codices and check if you're on version 3, right? Okay, so you go to easy OPC, then you go to, okay, I get it initially you are here. So you go to codices there at the end, and then you go to settings codices and make sure you're on V3. And then you click OK. And then once you're done with that, you must click play here, right? And then there should be a change of status. The change of status. Oh, and also here, before that, also you have to log in here, right? So let's just stop here and go to codices and then log in, download. And then press play, right? And then on Fluid Sim, you must also press play. And then you must, your codices must be connected to localhost. Is it still not connecting? Yours is fine now. Can you assist him on how he did it? just like, as I said, sequencing. So first things first, like make sure everything is off. Make sure like you're not in simulation mode. And then once you're off simulation mode for all the softwares, for example, like this, let me do this. So when you're here, right, before you close your simulation, go to stop, right? This square, this blue square, right? You stop and then you log out, right? And then also make sure this side you are logged off, right? And then on your codices, yes, yes. Someone said say. Sorry, can you speak up? Guys, I'm gonna, for the rest of you guys, I'm gonna continue. I'll just have to go back to the recording, right? Because yeah, we're out of time even now, and we have to start making progress, right? In the next session, there won't be like, we won't be going through this setup, and we'll just be straight going to the programming, right? Because you have wasted a lot of time, right? So just go through the recording again. So yeah, so once you have connected, right, we're just now gonna build a short program, right? This program, it's like a testing program. You want to test if your ladder logic is working, right? Now, how you do that is by using inputs and outputs. Since we've already defined our inputs and outputs, we now have to put them in the form of a ladder logic. So your input in the form of a ladder logic is by contact, right? So a contact symbolizes your input, right? So you're gonna click that, and then it will appear under your what's this, your variables there, right? And we said our first input is what you call, it's I0, right? Which is our start button, right? And then we said our output is solenoid 0, right? So which is Q0, which we have already defined. So first things first, you're gonna yes. This window, it's there. It should be there. Huh? You mean this one? It's blank. Okay. Hmm? So this is this. You mean this? This is a contact, right? It symbolizes your inputs. Huh? Oh, so at the top left corner there, you'll see an insert contact. Right? You just click on it, and then it'll appear there. Huh? You mean this one? This one here. Great. Okay, so what you have to do, is like, can you see, look at my cursor? If I click here, this thing is just white. But if I click into it, next to it, you'll see that it's yellow. Can you see? Make sure like the background, it's yellow. And then you'll see that your items are now available. Yeah. Guys, okay, I'm gonna maybe do this. Like, just look at the screen, because it seems like when you are looking at your screen and I'm doing things, you are doing your own things, and I'm moving ahead. So just look at the screen, and yeah, you'll just try following in your own time using your laptop, right? So as I said, we are now gonna do a what you call a test run, right? So this test run, it's a basic program whereby we want, when we compress our start button, for the cylinder to go forward and the cylinder to go back, right? And then after the input, we'll have an output. An output is symbolized by what we call a coil, right? So you're gonna click on that coil. So first you click on this rectangle here, and then you click on insert coil, right? And then this coil represents your output. So you're gonna say Q0, right? And then after this, this is our first basic code done, right? Now, after that, you're going to have to now log in with download. And then you can either click on login with online change or login with download. It's not really a big difference, but just make sure you choose the first two, right? And then you click OK, right? And then you click play, right? Okay. So what you must observe is on this view, you are having a blue line there. This blue line is your current flowing through, right? Now, at the moment, because this contact is normally opened, current cannot flow through, right? It'll only flow through once the contacts close, right? So that they can allow the current to flow. And yeah, it's also because our start button is normally open, right? But once you compress your start button, the contact will close and then the current will flow to Q0. And then it'll allow the cylinder to go forward, right? So how you see that it's working, I'm just going to split my screen and I'm going to just press play this side. But always just make sure that you're connected to localhost before that, right? Okay, so what should happen is once we press our start button, the cylinder must go forward, right? So I'm going to press. So as you can see, I'm pressing, and then once I remove my finger from the push button, the cylinder goes back. So I'm just going to do that again. The cylinder goes forward, and then it goes back. Once I remove my finger from the from the start button, right? Okay. Now, say that you want to use a. Now we're building on top of this, right? Now I want you to know that with this kind of a circuit, it's not standard practice, right? By that I mean it's not having your stop buttons, it's not having your emergency stop buttons, right? It's very important that you always have stop buttons and start buttons, right? And the other thing is, I said that we want our cylinder to just stay forward, right? Now I'm going to introduce latching, right? So latching, as you might know, is you want your circuit to hold memory, right? And you want your cylinder to constantly be having current. In the pneumatic sense, it's like you want air constantly going to your output, right? How you do that is by latching, right? Latching, you could say that it's also a parallel circuit connection, right? But you'll see it as we are building it. So when you're building, you're gonna stop again, and then you're gonna log out, right? Then you're gonna go back to where you were initially. Now, as I said, what we want for this exercise, second exercise, we want to latch. We want the cylinder to stay in its advanced position. It'll only be stopped. It'll only retract via a stop button, right? So how you do that is by now connecting your input in parallel with your output. But when you're latching your output, you use a contact. And not a coil, right? So you'll see what I'm talking about. So you're gonna click on this line before I0. Before I0, you're gonna click on this line, and then you'll right click, and then you will say insert contact parallel below, right? And then you will label this contact as Q0. Now you can see we have Q0 as an output, then Q0 as a contact. When you have established that kind of a connection, you have successfully latched your circuit. By that we mean that constantly your Q0 will be receiving current, right? So let us put that into practice. So let us log in with download and see what will happen to our cylinder, right? Okay, and then we're gonna log in with online change. Okay, and then let me just do this. Okay, I want you observing some things, right? a few things before we run this, right? I want you to observe that there's a table, right, of your inputs and outputs at the top of your program. Now, we have values here. As I said, when you were putting in your inputs and outputs, at the end you put like a data type called bool. So that data type, it takes two values, true and false, right? Now, your I1, right? Your I1 and I2, what are those? Your I1 and I2 are your push button stop and your emergency stop. As I said, those ones are normally closed, meaning their contacts are normally closed and always allowing current to flow through, right? So you should see that they are true. If you see your value being false, it means you didn't use the right push buttons, right? So that's one thing you should take note of, right? So yeah, that's, but we'll always go back to this table so that I can explain some other things, right? So for this program that we've just now created is gonna allow us to have our cylinder remain in the forward advanced position, right? So as I said, this is a latching exercise. We are now latching our circuit, right? So we're gonna press play here, start, and then we're gonna go back to our what you call our circuit this side, right? Okay, so if you press your push button, you'll see this happening. You'll see that your cylinder goes forward and it doesn't come back, right? Initially, when we pressed and released our finger from the push button, the cylinder went back on its own. Why? Because it has a spring. But we have in a way, we have configured our circuit to latch, meaning that our cylinder constantly receives air. As you can see by this dark blue light, right? Dark blue color passing through your tubes, right? This means that your cylinder is constantly going forward, right? Now, you always want to stop your process, right? How you will stop that is by using a push button stop or your emergency stop, right? So say there's another object and you want to also maybe drill it, right? So you're gonna want your cylinder to go back so that it can go forward again, right? So now we're gonna introduce like the push button stop. So a push button stop will now break the circuit. By that I mean it will allow our cylinder to go back to its retracted position. So how you do that is to put okay, we're gonna first stop and then we're gonna also log out here. So how you do that is by clicking on this line and then inserting a contact. Remember, your inputs are characterized by these contacts. So we're gonna put I1. I1 is our stop button. Right? Remember what I said. Your stop buttons are normally closed. So current will flow immediately through this contact, right? If it was normally opened, right, current wouldn't be able to flow through your circuit, and it wouldn't allow you to break your circuit, right? So just keep in mind with that, right? So we're gonna now press login. Okay, first we're gonna just go out of simulation mode here. And then you're gonna now simulate here, login, and then log in with online change. Okay, I want us to observe something also. For your output to work, right? All your contacts, they should be in series and they should be on. The state should be on, right? Now, as I said, I1, its state, it's normally on, right? Meaning current can flow, right? Also, this Q0, it must always be on. for your output to work. Now, the only contact that's not allowing your output to work is your stop button. I mean your start button. Because why is that? It's because your start button is normally opened. So you must first press and close the contacts so that current can flow through to your output. Right. So we're now going to observe. Since we have put a stop button, we're gonna see that once we press our stop button, our cylinder will go back to its initial position, retracted position, right? So remember to always press play. Okay, and then you'll go to your flow sim and press play here as well, right? Then once you press play, you'll see that the cylinder automatically goes forward. I mean, not automatically, obviously. It goes forward after pressing your start button. And then once we compress or press our push button stop, you'll see that it'll go back, right? And then it'll go back to its retracted position. And then right there and then you have broken your your circuit. That is, you've enabled your cylinder to go back. Now, the other key thing you should observe is once you press your stop button, it remains open now. It's no longer closed. As you can see, the contact was closed, but now it's open. So should you want to press again your start button, nothing will happen. It will just look at you and say, "What are you doing?" Right? So the only way to reset that is by pressing again your push button, and then you'll see that now. Sorry about that. So once you close your contact by pressing on the push button stop again, you'll see that the line is red, meaning it's closed now. Right. The same works with the emergency stop button, right? Of which I'll show you guys. Okay, which will be the last thing we do for today. So now the exercise now that we'll be doing is now stopping our process using an emergency stop button, right? So we're just gonna stop that simulation and go back to our codices. And then we're gonna stop there and then you're gonna log out, right? Okay, we're now gonna add our emergency stop, right? So how you do that is click on the line and then you insert another contact, right? And then you label that I2, right? Remember, your stop buttons are normally closed, right? Just keep that in mind, right? So once we've put that on the diagram, we can now log in and then press OK here. And then we can press play here, right? Okay, so what you'll observe is now that we have put our contact, our stop emergency stop, you'll see that when you come to our fluid sim here, we can stop our process using an emergency stop. Otherwise, I mean, we can retract our cylinder using an emergency stop, right? So I'm gonna press play here, and then I'm gonna start our process, right? So the cylinder will go forward, and then once we press our emergency stop, our cylinder will go back, right? But you must observe something again. Your contact now, it's closed now. So, I mean, it's open, it's no longer closed. And also you can see by the port number 2 here on your fluid sim out that it's now white, right? There's no current flowing through. So should you want to run again your machine, nothing will happen. Because why? Current is not passing through to the output. In this case, air is not passing through to the cylinder, right? It will only happen once you activate your stop button, and then if you press again, the start button, you see that it goes forward. And observe also, once your cylinder is forward, you'll see that also your Q0, the line, you see a red color there on your line, meaning that there is air or current flowing, current in the sense of PLCs, or air in the context of pneumatics, right? You'll see that current is flowing through your contact, right? I mean your outputs, right? And then you can stop the process by pressing emergency stop. Okay. Okay. So in next week's session, we'll continue building from here, in a sense that we will now introduce timers to time our process, right? We'll introduce on delay and off delay, right? So I advise that you start familiarizing yourself with an on delay and an off delay, right? So yeah, that's what we'll be doing in the next session. And just go through this recording to, yeah, in practicing how you set up communication between the software, and yeah, I'm sure you'll be okay moving forward. Otherwise, you are free to consult anytime. We work from 8 to 4 o'clock. So yeah, if you need clearance with anything, you know our office in 1304, right? So yeah, that's it for the session, guys. Enjoy the rest of your day.